Alright, so it says that the legs of a right triangle, so I'm going to draw a right triangle. Remember, a right triangle has that 90-degree angle. Okay, so the legs are 4 and 5 miles, and we want to find what is the closest to the hypotenuse of the right angle. So our hypotenuse is this one. That's our C value all the way, always across from our 90-degree angle. So that's what we're looking for. And then 4 and 5, it doesn't really matter which way we put them. I'm just going to put 4 then 5. Okay, so 4 and 5 are your A and B. Again, it doesn't matter which way you put it. If you put 5 squared then 4 squared, it's fine. If you put 4 squared then 5 squared, it's also fine. Okay, so if we did 4 squared, we'd get 4 times 4 is 16. Good. What's 5 squared? 25. What's 16 plus 25? Perfect. And then what is, we have to take the square root to get rid of that squared on that C. Okay, so what is the square root of 41? 6.4. Awesome. Okay, one thing to look at this, if you were like, I have no idea what to do because you didn't remember the Pythagorean theorem, you could have at least eliminated these two, because we know that that hypotenuse has to be the longest leg. So 3 and 4.5 aren't longer than 5 or 4. So you got to make sure that your answer makes sense too when you do it. So you could have narrowed it down to 3 correct answers rather than the 5 that you had at the beginning. So that's just like a test-taking strategy. If you were taking the ACT or your Kansas State assessment, which you guys will do this year, at the end of the year if you're a 10th grader, it's good to try to eliminate the ones that you know for sure aren't right. That way you know it makes sense. Okay, so continuing on with today's lesson, we are on 3.5. We skipped 3.4 because it's a longer lesson than 3.5, and today's a shorter class period, so the shorter lesson is coming on the shorter class period. So, hypotenuse leg theorem. The hypotenuse leg theorem of triangle congruence theorem is the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of the second right triangle if both triangles are congruent. So for this one, we just need a hypotenuse and a leg of both triangles to make sure that they are congruent. Okay. Alright, so first things first, we are given this diagram. Okay, so on this diagram, I know that MN is congruent to, PQ. So MN is congruent to PQ. Why? Because that is given to us. Whoa. Alright. Is there anything else we're given? The angle N and angle P are right angles, right? Or congruent. So angle P is congruent to angle N. Okay, and that is also given to us. Okay, so that's all we're given. Is there something that we can assume is congruent? What about this one? What property says that QM is congruent to QM? Yeah, the reflexive property. Good job. So when they share a side, that's the reflexive property that we use to say that they're congruent. So here's the thing. Normally we would label these with A's and S's, right? If I label this with an A, an S, and an S, and an A, and an S, and an S, if I read it as I go through the triangle, what does that spell? ASS. That's the bad word, right? So normally that does not work. This is the only exception to the ASS rule. Okay? Because this is our hypotenuse, because it's opposite of our 90-degree angle, and this is a leg, the only time if it spells out that bad word, you check for that 90-degree angle and see if it's actually HO. So since it's HO, we can say that triangle NMQ is congruent to triangle PQM because of HO. So it's the only exception to the ASS rule. Any questions on that? Okay. Alright, so on this example, we are given the diagram, and that triangle WZX is quadrilateral. Or sorry, equilateral. That's awkward. Alright, so our diagram says that WV is congruent to what? What's it congruent to? Someone? Yeah, there we go. So WV or VW is congruent to IX. That is given to us. Okay, we're also given the angle V is congruent to angle Y. That is given. And then the last thing, we're told that triangle WZX is equilateral. Does anyone remember what equilateral means? Yeah, all the sides are equal. So that means that WZX, this triangle right here, all three of these sides are equal. So that means that WZ is congruent to what one on this triangle over here? Perfect. So WZ is congruent to ZX because the definition of equilateral triangle. Okay, oops, I forgot to write given on this one. Okay, so now we would label our angles and sides, and it would be ASS, which is a bad word. But if we look closer, we have a 90-degree angle, right? So we're given this one is our hypotenuse, and the other one's a leg. So our reasoning is going to be HO because the hypotenuse leg, and then what we're trying to prove. So triangle VWZ is congruent to triangle YXZ. Okay, go ahead and try the guided practice below. I'm going to give you a couple minutes. I'll be around to ask questions. Alright, so the first line is always what for the reasoning? The given. Okay, so that one said that JK is congruent to KM. Okay, we're also given that since this is a straight line, right, this angle would be 90. What would the other one also be? 90 degrees, right? So angle JLK is congruent to angle KLM. Okay, and then it tells us to use the reflexive property, which right here is where our shared side is. So it would be KL is congruent to KL. And then we would label it out. We'd get ASS, which is no good. But if we look a little bit closer, we got our hypotenuse and our leg. So this would be because of HO. Sweet. Goodbye, recording.